A paper entitled Predicating Phrase Breaks in Classical and Modern Standard Arabic Text by Magdi Tawalha, Claire Burley, Eric Atwell, presented by Rasha Ibrahim Musa Ahmed. Junking text or sentence to determine its boundaries is a natural language processing and machine learning task. We can junk text via automatic assignment or sentences and subdivide inputs into meaningful chunks. This attempt to simulate human parsing and phrasing strategies and classifying gender between words into finite set of boundaries types such as breaks and non-breaks. Research question. The research questions pertaining to this study are as follows. Can we learn any reliable prosodic syntactic boundaries pattern from Arabic from coarse grained data? Which basic pattern emerge to differentiate major and minor chunks boundaries? Which sequence model n-gram or HMM tagger gives best results with coarse grained features? We trained and test two probabilistic taggers for Arabic phrase breaks prediction on a purpose built gold standard boundary annotated and part of a speech tag or an corpus 77,430 words and 8,230 sentences. Here we report and comparative experimental which of the cells n-gram and HMM tagger and coarse grained feature set for syntax and prosody, where the task is to predict boundary location in an unseen text set stripped into boundary annotated by classifying words as the breaks or non-breaks. Corpus of Quranic Arabic. The sentences were not randomly selected. We choose Quran as experimental dataset and we regard it as a reputable gold standard for phrasing in Arabic because originates from the Prophet period of residence in Mecca or Medina. The availability of an open source of Quranic Arabic corpus, Dukes 2010, it comes complete with its own system of stop and start as one component of traditional recitation, markup or tajweed. Denny 1989. The original 8 tajweed categories consist of 3 major boundary types, 4 minor boundary types, 1 prohibited stop. 1 and 2 annotated by the given marks. The figure shows corpus data from which they extract features as input tagger. Ar-Rahman means the most gracious. It is a name or nominal. The boundary type is non-break. And Rahim means most merciful. Also, it is a name or nominal. The boundary type is break. General procedure for phrase break prediction. Prerequisite. Phrase break prediction assume prior sentence segmentation and part of speech tagging for input text. A prerequisite. Developing and evaluating phrase break classifier is a gold standard boundary annotated and part of speech tag corpus. Punctuation and syntax are traditionally used as the classificatory factors. Another prerequisite is a boundary annotated and part of speech tag corpus, EBIT, as a gold standard for developing phrase break classifier. The classifier is trained on a substantive sample of gold standard boundary annotated text and test on a smaller unseen sample. Machine learning approach to phrase break prediction. There are two generic approaches to machine learning: rule-based, probabilistic. Phrase break model exemplify these two approaches. Lieberman and Church-Jenk, N-Jones algorithm 1992, Taylor and Plack's Markov model 1998, Taylor and Plack's statistical model conditions the probability of junked type. Metric for phrase break prediction. Performance is primarily evaluated in terms of accuracy. Number of correct prediction equal true positive plus true negative made during test. There are also other relevant metrics. F-score, the former trade-off between total of true positive over total number of boundaries in the sample. Balanced classification rate. This metric mitigates against high accuracy score arising from class imbalance. A typical scenario for phrase break prediction, since instance of the majority class non-breaks greatly outnumber minority class instant breaks in the corpus. BCR is computed as follows. BCR equal half by true positive over total true positive plus true negative over total true negative. The trigram tagger was implemented based on the Natural Language Toolkit Baird et al. 2009 to assign boundaries to corpus of Quranic Arabic, which is segmented into 8,230 sentence token part of speech tag. Each sentence token is represented as a list of tuples. An HMM or sequence model based in Natural Language Toolkit was implemented, also had a Markov model tagger class. Trigram tagger. Quran trigram tagger is coded in a Python and trained on Quran represented as part of speech boundary type or word part of speech boundary type bearings. Figure 2 give a sample of Quranic sentence, Arabic words, and part of speech tag bearing are mapped to boundary type and serve as input features to the classifier during training. This is the noun boundary type non-breaks. Allah noun boundary type non-breaks. Ar-Rahim noun the boundary type non-breaks also. Ar-Rahim noun breaks. Methodology. To address the research question, we comparatively evaluate the performance of a trigram tagger and HMM tagger firstly on our Quran dataset. The first round of experiments used tripartite part of speech categories, noun, verb, and particle to predict breaks versus non-breaks, boundary of types, major, minor, and none. The second round uses 10 part of speech features to resolve post-task binary classification and the 3 class problem. The training set comprises 70,112 words and 70,381 sentences. The test set comprises 7,318 words and 849 sentences. The number of sentences in the test set also equates to the number of major breaks in the test set. Non-breaks in the test set total 6,469. Total subdivided into 600,261 non-breaks and 208 minor breaks for the 3 class problem. Confusion matrix. Output predictions are presented as a confusion matrix where false positive and false negative are used to infer basic issues in performance. Tagger accuracy for each classification task can be expressed as follows. Tagger accuracy percentage equal summing of the number of correct prediction for each boundary type over the total number of items to be classified. Table 1 is the example of confusion matrix for the 2 class problem using the binary classification where part of speech peer. The shaded area in the table count constitutes the correct prediction true positive and true negative retrieved during test for our trigram tagger. Also, we notice that the class distribution in the test set are highly skewed. 6,261 non-breaks versus 1,057 breaks. The 2 class problem. Table 2 display results for binary classification experiment with both tagger and feature set words part of speech tag and Quran test set 7,318 words. What is immediately obvious is that skew set a high baseline accuracy of 85.56%. The trigram tagger in run 1 and 5 significantly outperforms the baseline for both syntactic feature set, 88.47% for 3 part-of-speech category and 88.44% for 10 part-of-speech category. Success rate for HMM tagger is below par. We therefore use the alternative metric of PCR. The trigram tagger in run 1 correctly predicts 380 bricks, set against baseline prediction of 0. Hence, PCR for run 1 represents significant gain in performance. What is additionally interesting is that the HMM tagger in run 2 and 6 also represents significantly gain in performance in terms of PCR, even when set against run 1. The 3-class problem. Table 3 records results for tripartite classification. Significant gain in both accuracy and PCR over baseline performance were achieved by trigram tagger for the 3-class problem using both feature sets in run 9 and 13. 88.69% and 88.62% respectively. The HMM tagger also achieved significant gain in terms of PCR run 10 and 14. Conclusion. After classifying words as bricks or num-bricks, the pre-boundaries of num-bricks in the training dataset, a challenge baseline success rate 85.56%. We achieved significant gain in accuracy with the trigram tagger and significant gain in performance recognition of minority class instance with both tagger via balanced classification rate. Future work. The trigram and HMM tagger in this experiment are prototyped using fairly coarse-grained syntactic feature only. Our plan for future research including enriching our dataset with very fine-grained morpho-syntactic analysis using the standard Arabic linguistic morphological analysis tag set. Salma Tagger, Sawalha 2011, Sawalha and Atwal 2010. More fine-grained boundary annotation, projected prosody. This is initial work on a long-term research project to produce a notation scheme, language resources, algorithms, and application for classical modern standard Arabic. References. The end. Thank you.